If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. A little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends at York University. I'll be one of your three hosts this evening, joined by Mr. Planetarium himself. Hey, Ryan.
Greetings.
And salutations, too. And, of course, the ever-reliable, ever-present Julie.
Hi.
Party of three, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And, of course, it is Monday night, therefore it is Astronomy Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York Universe, on to Western World's Quirks and Quarks, not to mention Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That's therefore Eastern Standard Time here in North America at this time of the year. That, of course, means Tuesday morning, 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, team. It runs, not surprisingly, between the hours of 9 and 10 p.m. local Toronto time. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to online public viewing. By the way, you can also find us through your favorite YouTube connection. Just put in the search bar Allan Carswell Observatory. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about past shows, or if you have suggestions for future topics, please send us an email, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory. And Facebook. Sorry about that. Tripping over too many handles here. And on Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, see our website, observatory.info.yorku.ca, and look for the big button in the middle of the page. We will be monitoring the chat room as well. We have cloudy skies. In fact, it's been fairly snowy here today, so no live viewing tonight, but lots of wonderful archival images. So, folks, it's 40 days to Christmas, okay?
Winter hath arrived.
That, too. It's funny white stuff on the ground today all over here in King City.
That plus the time change, and that's it. Canada has gone into hibernation. For anyone outside of our country, talk to us in March, maybe late March.
True enough in many senses. But you know what? It means long, dark nights where I can be observing by 6 o'clock in the evening. I mean, I think that's personally wonderful. What astronomer doesn't like the idea? Yeah, November is not cool. But it's going to get better. I am the forever optimist. Come January, long, cold, clear nights. The mechanical shop people will shudder at the phone ringing with Paul Delaney at the other end. Can you come up and handle cold metal at minus 20 Celsius? No, no way. How about you, Julie?
I'm doing all right.
Done any observing of late?
No.
No.
That would require me to have time to do such things.
Right, Mum. I understand.
I look up when I go outside and it's dark and clear.
Well, that's good. If you can see a couple stars, that's good. But you reminded me, Julia, not having time to observe and being a parent, I bought a solar scope for that purpose because I realized I'm losing half the day of observing.
Yes.
Because the sun is
true.
up.
That's right.
So I got a solar telescope.
Very nice.
Darn good logic, that.
Now I can avoid observing twice as often due to weather and cold and whatever other reasons I.
You were doing so well up until that comment. I was impressed. Well, you'll at least be able to teach your son the do's and don'ts of safe solar viewing from a very early age. He can give a presentation at his kindergarten class in a few years.
Oh, I look forward to that.
Absolutely. Absolutely. Julie, would you like to lead us off with This Week in Space and Astronomy History, please?
Absolutely. So we are starting with November 19th, 1996, and the launch of STS-80. This mission was flown by Space Shuttle Columbia and was originally scheduled for an October 31st launch, but it was delayed for several reasons, including the redesigned solid rocket motor nozzle had some erosion on it that had to be taken care of. There was a fuel pump failure, and then when everything was ready, there was bad weather for a few days. It was the longest space shuttle flight, lasting 17 days, 15 hours, and 53 minutes. There were 2 spacewalks planned, but they had to be canceled because there were problems with the airlock and the astronauts could not get outside. Some highlights from the mission: they deployed 2 satellites and successfully recovered them once the tasks had been performed. Astronaut Story Musgrave became the only person to fly on all 5 space shuttles. And Musgrave also tied the record for a number of space flights and set a record for being the oldest man in space. Both of those have since been surpassed. The 2 satellites were on repeat visits to space. So they were designed to be released by the Canadarm, do their thing, and then be picked up again. So the first one was the Orbiting and Retrievable Far and Extreme Ultraviolet Spectrometer Shuttle Pallet Satellite 2, or Orpheus-SPAS 2. And
okay, sorry.
That is a mouthful.
It sure is.
As an acronym. And it had 6 experiments on board. And then the other facility was the Wake Shield Facility, WSF-3, and that created a vacuum in its wake and was used to study epitaxial film growth, which I had to look up what that meant. It has to do with crystal growth, and it led to the first ever crystalline semiconductor thin films in the vacuum of space. There were a number of other science experiments on board, including the Space Experiment Module, or SEM, and the SEM included Student Research Project selected to fly to space. And that was the first flight for that program. Among the other experiments conducted were analysis of bacteria growth on food in orbit, crystal growth in space, and the microgravity's effect on a pendulum.
Busy mission, whichever way you want to cut it. I did not know, at least I had forgotten is probably a better way of putting it, that we couldn't actually get out of the airlock. That was certainly an unusual problem for the shuttle.
Kind of concerning too, right? Like,
yeah.
What if they had to get out?
Exactly right. The only thing I can think of there is that, they were concerned that they were going to end up with a depressurization situation for the rest of the habitat area. So better safe than sorry. So they just didn't bother using the airlock at all. But as you say, very disconcerting.
I suppose it's better to be locked inside than outside.
True. Very true.
Fair enough. That's
at least in the interim. But I was thinking about this, and I was curious about how, this is 1996, and they're doing crystal growth and bacteria growth, microgravity on a pendulum. We talk about the space program and how many things how many technologies on Earth have come from the space program. I wonder if there are some examples of that in the last kind of decade, 15 years. I keep meaning to look up something like that because I'm really curious.
Don't know. There were so many things that were accomplished, and there were so many things that I've obviously forgotten that they accomplished. I'd have to look it up too. Can't give you an answer just off the top.
No worries. I certainly wouldn't ever try to stump you, Paul. You would just put me in my place. But it was just more of a thought as Julie was talking about the different experiments, and those are really fascinating. I wonder what has come from them, because I was thinking of semiconductor thin films, often grown here on Earth, and how much benefit growing them in space was to the research, and what that led to. And I'm sure there's a lot of things that I probably don't have the engineering background to either understand or keep tabs on, but I'm certainly very curious about kind of the more recent technological benefits of space flight. So that's something I'm going to put a pin in for myself to look up in the future.
And of course, sometimes it will be very hard to pin down and say, okay, that particular experiment has really led to the following. More likely that, there are these incremental types of aha moments at these sorts of experiments, and we're referring to crystal growth and so on and so forth, but an aha moment that led to something else that led to another aha moment, and all of a sudden it ends up with a pattern that we might be using in our everyday lives, but nobody ever puts two and two together to conclude that the genesis of that research actually happened in Earth orbit. It's sort of too far back down the science chain for people to automatically associate, yes, this particular breakthrough happened because of activity in orbit.
I suppose that's true with science in general these days, right? The growth of scientific knowledge has become so incremental and so precise and diverse subfields now that the big sweeping changes of the 1960s and 70s effect on technology from the space program probably won't be seen again.
That'd be my take on most of science. But of course, at some point, for example, if we ever do generate something approaching warp drive, I mean, that will be a big sweeping exclamation mark in the history books. But apart from that, I'm not even convinced that will ever happen. But apart from that, all of the sorts of science that, we collectively talk about is very incremental. But the pace of those increments, I would put it to you, have probably increased over the last 20 or 30 years.
Yes, indeed. Yeah.
And, of course, as a complete piece of trivia, Story Musgrave, I'm going to put that down in my little trivia book here, flying all 5 shuttles. Nobody else ever did that. Yeah.
Wow. That's cool.
Good. Yeah, very cool. Very cool indeed. Ryan, where would you like to take us? Above and beyond?
Not so much. This is more of a personal one that I really wanted to talk about. And I was looking through some old astronomy pictures of the day for the past few years to try and get some ideas for astronomy history. And it called back to a question that a student asked me just last week in a virtual program, a grade 5 student. And they were asking me about eclipses. And we talked a lot about solar eclipses and lunar eclipses, as we're going to hopefully mention later in the show. But the student asked a question about, hey, do eclipses happen with other celestial bodies? And I thought that was really interesting to think about. And I was like, yes, of course, we call them conjunctions, but they happen all the time. And it got me thinking about Mercury and Venus. Now, of course, the last transit of Venus in 2012 was the last that we're going to see in our lifetimes and for a couple of lifetimes. But Mercury, I talked about, and how Mercury will undergo 14 total transits of the sun in this century alone. So much more common than the transit of Venus by virtue of it being much closer to the sun. And so I thought that was really interesting. And this past transit of Venus happened, and here's the historical piece, November 11th of 2019. So just about 2 years ago. And I remember watching it myself on the solar disk. What was really interesting about it was that it was during the most recent minimum in the solar cycle over the past 11 years. And so we didn't really see any sunspots on the solar disk. It was a very calm, quiescent sun. And to have this tiny little dot that is 1/200th the apparent diameter of the sun, it was very easy to pick out Mercury crossing the disk of the sun. And I said to this student, we, as general observers, if you're looking at the sun, you're not going to see anything. You need a solar telescope in order to properly observe it, or at the very least a pinhole camera. to take a look at it, even with some difficulty, as it makes its 5.5-hour transit across the solar disk. But still an amazing thing to see. And as I said, this was actually the fourth of Mercury's 14 solar transits that will be happening this century. So the next one will be actually quite a ways from now, November 13th, 2032. And Paul, I see you've corrected my date for the Venus transit pairs. I couldn't remember how far apart they were. It was 140 years, is that right?
Oh, it's actually only about 110.
Well, there you go. So I was wrong twice. That's wonderful. But thank you. It's still at least not in my lifetime, and that was the first thing I said. So
that was correct. It's not in our lifetime, so that's why I didn't jump all over you there. But
I appreciate that. I was sufficiently vague as to not earn your ire, but but it's one of those things with Mercury's transit that if you have some kind of relation to astronomy circles, amateur or professional, it's something that you're going to want to see, or something that you're going to strive to see in your lifetime. And the student then, went on to ask me, well, does this happen with other planets? And I said, well, there are certainly conjunctions with other planets, but the only reason we can get Mercury and Venus from Earth is because they are the inferior planets. And I always love mentioning that because it's like, Mercury and Venus are inferior to the others. It just means that they're closer
Yes.
and can actually pass between the Earth and the Sun. So I always get a good laugh out of that, as do the students, although they might be laughing at me more than at the particular joke. So at any rate, Mercury transiting the Sun 2 years ago, November 11th, was the fourth of 14 solar transits this century. We're going to have to wait a little bit of time. The next one will be just under 11 years from now in 2032. So mark your calendars, November 13th, 2032, for the next solar transit, the solar eclipse by Mercury.
And just while we're talking about sort of when Mercury gets around to doing these things, it only ever happens in the months of May and November. It's just quirky, the orbit that it is in, and when it actually gets its act together to be in an alignment with the sun from our perspective, it only happens in the months of May and November. I think I've watched 4 or 5 of them now over my lifetime, and 2 or 3 of those at York. They are neat. Mercury, it's not as big as Venus, so it's a little harder to see. But when you mentioned the fact that it was during solar minimum, I tell you what, it made it a whole lot easier figuring out which point was moving. But yeah, they are neat to watch, and because it is slow and methodical, students can have a look through the telescope. They can go off to a class, come back an hour later, and realize, you're still here and it's moved. And there is something to be said for this sort of long process that the Venus, the Mercury transit engages in.
It's the rate length. It's like it's not 30 days.
No.
The rotation of the sun, where you have to come back again and again and again and again. But it's also not 10 minutes. And if you blink, you'll miss it.
That's right.
So that, like an ISS pass of the sun. That's really kind of ideal for younger people, for students to go and observe this, and for amateurs and professionals alike to actually enjoy it. As you say, they can go and do something else for a couple of hours, come back and notice the movement and maybe snap a photo and actually see the difference and produce something functional and interesting.
Correct. Quite correct. I can't remember whether or not it was, I think there was one in 2015, May of 2015, and we were observing it from York on the apron there in front of the stadium. Mm-hmm. And there weren't a lot of sunspots out, but there were enough that you could actually get a nice comparison between Mercury and the differing sunspots. Some of the sunspots were smaller and literally, seemed to be smaller than Mercury, although they were probably comparable in size. Mm-hmm. And then there were others which were obviously distinctly larger than. And so again, it's a very useful, teachable moment because you can then start talking about sunspots as Mercury is quietly drifting by.
I enjoyed that. I remember that one. I think you're right. I think it was 2015. And I was at the Ontario Science Centre watching it, brought out one of the big Dobsonians that they had, pointed it out the window and showed it to everybody who was walking by. So that was a nice one. I've only seen, I think, 2 of them in my life, so I've got some catching up to do, Paul. But
well, as you say, mark your calendar for 2031. Did you say
2032?
Right.
Yeah.
Exactly.
Bit of a wait this time, but that's okay. Not as long as the Venus wait. So.
Oh heck no, that's for sure. All right. Well, let me take you on a very recent day in history. I toyed with whether or not this was not far enough back in time, but I decided I'd keep it in anyway. Okay, so November 16th last year. So it's literally only a year ago, but it is a year ago. SpaceX's Crew 1 launched to the International Space Station, commencing regular rotation of NASA astronauts launched from U.S. soil. We've spoken many times about the culmination of the shuttle program, the flight of Atlantis back there in 2011, and how it was the end of an era. And then it took seemingly forever for us to get around to launching, again from Cape Canaveral, from the Kennedy Space Flight Center. But it did come about. The commercial crew program finally bore fruit, if I can use that term, came to fruition, maturity, et cetera, during 2020. And the first official crew rotation launched to the space station, as I said, on November 16th of 2020. The launch was just after midnight, and of course that meant a spectacular view. Nighttime launches are not to be missed. I remember the Apollo 17 one very, very fondly. I wasn't actually at the Cape, but it was broadcast on TV on the news hour, and I've watched it several times on YouTube since. Spectacular launch there with Apollo 17 back in 1972. But this particular launch last year was the first launch since the STS-131 flight, which was in April of 2010. The capsule, the Dragon capsule's name was Resilience. Okay, they loved naming the capsules after terrific moments in history, shall we say. Endurance, endeavor, resilience. I get a kick out of it, I really do. They were in orbit for the better part of 6 months, splashing down on May 2, 2021. And just again, as a little note in history, that was the longest flight of any U.S. vehicle in history. All of the space shuttle missions, as Julie just mentioned, the longest one was a little under 18 days in orbit. The Apollo flights to the moon and back were, generally speaking, under 2 weeks. Skylab 4 was the longest U.S. flight, and that was all the way back in 1974, and that was at 84 days. And so the flight of Resilience was certainly much longer than that, as I said, the better part of 6 months. The crew on board, because there were 4 crew, and this is really important with respect to the science implications for the International Space Station. It was able to take up 4 crew, and it's continued to do that with all of the ensuing crewed missions from SpaceX. It gives a whole extra person available for science on board the International Space Station. It bumped the regular crew rotation of 6 up to 7, and that 7th person is able to devote a lot of hours to science during the course of a week. So really important to be able to expand the crew of the International Space Station. For the record, the crew, Mike Hopkins, Victor Glover, Suichi Noguchi from JAXA, the Japanese Space Agency, and Shannon Walker. Victor Glover was the rookie on board this flight. They, of course, comprised expeditions 64 and 65. So, as I said, it's a recent This Week in History element, but a very important one. When we think about the ability of the commercial space program to be able to take people into orbit, not just suborbital like we've seen with Virgin Galactic and Blue Origin, but to be able to take people into orbit, both for, shall I say, business and pleasure. I'm thinking of the Inspiration 4 flight in September. The ability for the commercial space transportation system to be able to take people up to and return them from the International Space Station more or less at will. Very important step as far as our ability to inhabit Earth orbit and potentially beyond Earth orbit to the moon and so on. Very, very important milestone was the Crew 1 mission of November 2020.
So, Paul,
yes,
was
ma'am.
it in space that long because it was docked?
That's right. Yeah, it wasn't active. You're absolutely right. It flew up, and it probably flew up within a day or two. I can't actually remember its transit time to ISS, and then 1 or 2 days at most at the end. So it didn't do a whole lot up there.
I mean, it did an important thing.
Exactly. The fact that you had the reliability of a vehicle that you had docked at the International Space Station. But even the Apollo capsule that was docked with the Skylab 4, it didn't do a whole lot either. It just hung around for 84 days. It was just an interesting little footnote that it took us till 2020, if you will, into 2021, to have a US-based vehicle spend that much time in space. The Russian Space Federation, the Soviet Space Federation, they were routinely docking their Soyuz from the Salyut era in the 70s for 60, 90, 120 days. And then, of course, with Mir, they were docking them for 6 months easily and so on. But it wasn't until last year that the US actually matched that sort of technological feat.
Now we just have to make sure that we have a space station there for the foreseeable future to send astronauts to.
Yeah. We'll get to that.
We're going to get to that. You're chafing at the bit.
For several reasons. One more pressing than others. I still can't believe this was a year ago at this point.
Well, that's right.
The last year in humanity, I think, was just a quick flyby, right? And now we have a few missions.
That's right. Well, that's right. Crew 3 launched this past week, right? So, and Crew 4 is, I won't say it's on the threshold, but it's already set in motion for early next year. So, yeah, in a way, it seems like just yesterday. And in other ways, it feels as if SpaceX has been doing this, quote, forever. They haven't been, I know, but it sort of has that strange sort of feel. Just like, it seems like I married my wife yesterday, but it was 41 years ago. I mean, time has strange ways of dealing with the human mind.
Okay, one other question. So now there's 7 people living on the ISS,
mm-hmm.
which, if memory serves, that's the crew size it was designed for, correct?
Pretty well.
All right. So it took 20 years to get up to full occupancy.
Yeah. The first 10 years, of course, was the darn thing was being built. It was a really slow building house in that regard. And then, of course, we did also lose Columbia in 2003, and that brought the crew rotation size down for a while because we couldn't go up and back as frequently, and then we lost a couple of resupply missions. So it's had its share of challenges as far as full occupancy is concerned. But yes, it is now at the level that they had envisaged, a little longer getting there than had been planned, and let's hope that it stays that way for the next 4 to 8 years, because it's not clear how much longer the international community, the partners, will actually stay on board. They're committed to 2024. There are good rumors that they'll extend to 2028, but there are no guarantees in that. But nobody talks beyond 2028. So we'll have to see. Julie, keep us rolling, kiddo.
Sure thing. November 17th, 2016. And the launch of Soyuz MS-03. So this transported Expedition 50 crew members to the ISS. And these members were Oleg Novitsky of Roscosmos, Thomas Pesquet of ESA, and Peggy Whitney of NASA. It was the 132nd flight of a Soyuz spacecraft. And Peggy Whitson, at 56, became the oldest woman in space on that mission. Novitsky and Pesquet returned to Earth in June of 2017, but Whitson stayed on until September of that year, making her the woman to have spent the most time in space at that point. That record was surpassed by Christina Koch fairly recently, I believe. Whitson has quite the record as an astronaut. She's trained as a biochemist. She was the NASA chief astronaut for a while. Her first flight was with Expedition 5 in 2002. On her second mission, she became the first female commander of the ISS with Expedition 16. In 2017, she became the first female commander of the ISS. She holds the record for the oldest female spacewalker. She's spent a cumulative 60 hours, 21 minutes doing EVAs, which is the 5th longest on record. And after retiring from NASA, she joined Axiom Space, a private space company headquartered in Houston, and has been selected to be the commander of Axiom Mission 2, which is a SpaceX Crew Dragon mission that is scheduled to fly next fall.
And hence why my comment about SpaceX opening up the doorway to more transportation into and out of Earth orbit. I think it'll be very neat to see Peggy transition from her NASA role into this sort of, private astronaut role. A very accomplished woman.
Oh, yeah, absolutely. And when I was researching this, I was thinking, like I could name all the Canadian astronauts. I could maybe name 1 or 2 American astronauts, despite the fact that there are hundreds of them. And maybe it's because there are hundreds of them.
Yes, that's true. Absolutely.
I think it is nice that there are some other, not just opportunities, but other career paths for astronauts who have had their missions with NASA, the Canadian Space Agency, the European Space Agency. I think with private missions now, there's so much more open to former astronauts and current astronauts as well. So I think it's a good thing. It creates more space for new astronauts to come up the ranks as well.
And it utilizes the experience that these folks have gathered in their time with NASA, and hopefully that makes the private sector, shall we say, and the private astronauts that much more aware of what they are about to encounter and what they will have to face.
Agreed.
Truly.
Mm-hmm. Absolutely. Nope, really good stuff. Look forward to Peggy's flight next year. A quick tip of the hat to November 16th, 1974, and the Arecibo, rest in peace, radio telescope. It broadcast an interstellar message. Now, we've often been talking about eavesdropping on the universe, trying to listen for signs of extraterrestrial intelligence, the SETI searches and so on. But there have only been a couple of instances in recorded history where there have been deliberate attempts to broadcast a message of some sort out into the cosmos. And one of those occasions was this one on November 1674. I won't say the intended target, but where they were broadcasting towards was the globular cluster Messier Object 13, located in the constellation of Hercules. It's about 25,000 light years away, and they beamed this transmitted signal towards where M13 is today. Now, of course, anybody who's done a little bit of astronomy knows that the universe is in constant motion, that things are in orbit around the center of the Milky Way galaxy. When the signal, traveling at the speed of light, gets out to a 25,000 light-year location, M13 won't be there. So anyway, it's just one of those little faux pas. I don't know whether anybody was really thinking about it, but it sounded good that we were transmitting off to tens of thousands of stars, so as to speak. At any rate, we launched this message out. The message, I often talk about it in class. It's a bona fide message. There's lots of information in there, and I'll give a quick rundown of the sort of stuff that's in there. But anybody who has seen the graphic that encompasses all of this information, I look at it personally and go, you've got to be kidding. How would anybody be able to get this information out of it? Anyway, included in this graphic are the numbers from 1 to 10. Oh, that sounds pretty good. The atomic numbers of the elements hydrogen, carbon, nitrogen, oxygen, and phosphorus. Okay, and that makes up, of course, the DNA, the main atoms in the DNA molecule. The formula for the chemical compounds that make up the nucleotides of the DNA molecule, I don't even know those in English, let alone on this diagram. The estimated number of DNA nucleotides in the human genome, and a graphic of the double helix structure of the DNA. Okay, I recognize the double helix in this diagram. Okay, I give them that one. The dimension, physical height of the average man. Okay, it was a little bit sexist, what can I say? And a graphic figure of a human being, all right, more or less, and the human population of the Earth. Oh, no, I don't see that there at all. The graphic of the solar system indicating which of the planets the message is coming from. Yes, Pluto was included as a planet back at that point in time. That will really confuse the historians. And a graphic of the Arecibo radio telescope and its dimensions, the physical diameter, and the transmitting antenna dish. Okay. Aww. I'm sorry. You know, this was a really great exercise in I don't know what, because, you know, you can't read that out of this diagram. It's a low-resolution image. The important point is, though, that we had the technology to transmit signals into space. And if we had that technology, arguably other civilizations had that technology, and therefore the possibility of hearing those signals is real. How, you know, where do you look? At what frequency do you listen? What is the signal? I personally like the idea of prime numbers or something rather than this type of a graphic. But nonetheless, back on November 16th, 1974, the Arecibo radio telescope was instrumental in broadcasting one of the very few deliberate efforts to reach out to extraterrestrial intelligence in our galaxy. Long live the Arecibo Observatory.
What I think is really funny about this whole thing is including Pluto as a planet, because either some extraterrestrial race is going to look at this, civilization is going to look at this and say, what they got it wrong. Why is that tiny thing part of this big bell not, why are they calling that one of the important worlds? And if there turns out to be a ninth planet the size of Neptune farther out, they're going to be like, well, how do we know this is the right system?
Solar system.
So I think that there's an extraterrestrial intelligence out there who is laughing at us right now because we just haven't mapped our own solar system properly.
See,
never
for me,
actually thought of it that way.
For me, the funny thing is all this thing about DNA. It's like, please come to Earth, experiment on us.
Yeah,
see what makes us tick. Yeah, that's right.
Confirm you found the right thing by doing medical experiments on us.
We're not going to go down that pathway, folks. We really won't. Ryan, finish off our history lesson for the evening, will you?
Yeah, of course, with Arecibo, rest in peace. I thought about this story on November 15th, today, in 1988. Arecibo wasn't the first great radio telescope to collapse. The Green Bank, West Virginia 300-foot radio telescope collapsed on this day in 1988. It was a big dish. I mean, a 300-foot giant metal structure. And it luckily nobody was injured. It collapsed onto the building that housed all of its control mechanisms. And the engineering report that came a few days later said the collapse happened because of one single joint in the metallic structure that weakened and eventually gave way, which then weakened the next joint, and then that broke, and then that weakened the next joint, and so on and so forth until the whole thing collapsed. It's funny how that happens, right? But when you have something that big and that heavy, its structure is what keeps it strong. At any rate, I won't go into the joys of engineering and mechanical engineering and structural engineering. But a few things about this this great radio telescope. It could only move north-south, which I thought was really interesting because you might think, well, how's it supposed to look anywhere? Well, the Earth moves. So as the Earth works its way through the sky and continues turning, the north-south movement lets this radio dish scan the skies. And the other odd thing about radio telescopes that most people ask me about is, why does it need to be so big? They have to be large to collect enough of these very low energy, very long wavelength radio waves in order to get good observations. But luckily they do pass through the atmosphere basically unimpeded. So we can certainly use them on the ground. We don't have to worry about putting these giant things in space unless we want to do some interferometry, but that's a whole other story. However, the large size of telescopes like this does open the door to some wear and tear. They can require a large amount of funding to repair them, to replace them, to keep them in operation, especially with mechanical systems that have them rotate and pan up and down. And compared to a smaller optical telescope, they can't be placed in a dome to protect them from the elements. Now, in this particular case with the Green Bank telescope, after it collapsed, the first question is, well, can we replace it? That takes a lot of money. And sometimes when these terrible events happen, the money that is just not expected to come out to replace something like this just doesn't come out. However, the two senators of West Virginia at the time really fought to save the observatory. One in particular, Senator Robert Byrd, eventually did help to find funding for a 328-foot replacement dish that was named in his honor and still operates today. And they even upgraded it so that it could move not just north-south, but east-west as well to aim at particular targets. And so Green Bank, West Virginia, still has a great 328-foot radio telescope. And it does remind us that Arecibo was not the first to have a really terrible collision. However, we're still mourning its loss, having been a lot more recent. But this is what happens to radio dishes sometimes. And it is part of our search through the cosmos. And we need big dishes to do it. So we got to be pretty careful with building them.
There certainly are a large number of big diameter radio dishes around the planet. But of course, that said, we've now become very cunning, very ingenious. Think of the Atacama array. It's got a lot of much smaller elements cast out over a much larger area. And it, of course, is doing some phenomenal research. We need the big and the small, is the bottom line to it. There are a number of ways to examine the information that's coming to us from the night sky. It's not a one telescope size fits all research endeavors. So, I'm glad that we were able to replace Greenbelt. The question is, will we actually be able to replace Arecibo? There's been some suggestions that it would be replaced, but I haven't seen a groundswell, shall we say, to bring it back.
No, I mean, it's hard because FAST just opened in China. What was that, 2 years ago now?
Yeah, close enough.
So what's that, half a kilometer in diameter? That is unbelievable. Mm-hmm. And now, granted, it's not moving. It's just, it's
a transit instrument.
Yeah, exactly. Wherever the Earth is pointing, it's looking. But to be able to look at great depth. So, and you're right about, some of the arrays. There are very different ways to accomplish things, and they each have their radio observing, and there are pros and cons to each method, but we certainly are always on the side of more telescopes looking into space.
Are we biased?
Yes, but we accept that fact, and we give that in the disclaimer to all of our listeners.
Yes.
We are absolutely biased, and you should be too.
All the telescopes.
Yes, exactly. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here from York University in Toronto, Ontario, Canada. Ryan, Julie, myself, Paul, keeping you company through this week in space and astronomy history. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to online public viewing. Speaking of following that link and other activities out of the Allan Carswell Observatory, Wednesday night's Teletube. This is Telescope YouTube. By all means, join the observatory team as they meander through the universe, sometimes speaking with people, often looking through our 1-meter telescope. That's every Wednesday night from 7:30 till 8:30. Again, find your favorite web browser and open up YouTube and do a search for Allan Carswell Observatory. And you'll see all of the information there, past issues, past shows, and so on. Right. Well, we've got a couple of newsy items to bring your way. Julie, would you like to lead us?
Yes, absolutely. Apologies for my notification to go to bed.
Is that what?
I felt immediately tired when I heard that.
Okay, please stay awake for the next 20 minutes, okay?
Absolutely.
Thank
got
you.
my
Right,
word.
okay.
All right, on with the news. So fungi were able to absorb radiation on the ISS. So could astronauts grow their own radiation shielding in space? All right, so as you know, one of the biggest challenges to overcome as we send humans into space is to have effective radiation shielding. On Earth, the magnetosphere protects us, and the ISS is close enough to Earth to still partially benefit from that. And so we've had astronauts stay up there for up to a year. Over 1 year, the average person is dosed by about 2.6 millisieverts of radiation. And astronauts on the ISS are exposed to about 144 millisieverts. Astronauts on a 3-year mission to Mars would be exposed to 400 millisieverts. So we're getting into some pretty high numbers there. For comparison, the 5-year dose limit for nuclear energy workers in Canada is set as at 100 millisieverts. And radiation dosage is cumulative. There is no reset. So once you get up to a certain exposure in your lifetime, it's, like say you were in a job where you get extra radiation. If you get to this limit, too bad, you're going to have to find something else to do. Anyway, so in space, the radiation comes from the sun. It's produced by solar flares, and it's also comes in the form of galactic cosmic rays. So trips further out, like to the moon and Mars, will require some form of effective shielding. And in a paper by Graham K. Shunk et al. That was published as a preprint on bioRxiv, reports on studies of a type of fungus called, okay, I'm going to mispronounce this, but here we go, Cladosporium sphaerospermum. My apologies to any biologists listening. That fungus thrives in high radiation environments. So the fungus actually uses the radiation to grow in a process that's analogous to photosynthesis, and it's called radiosynthesis. And because it's absorbing the radiation to do radiosynthesis, it's also blocking radiation from passing through it. So on Earth, the fungi are found in extreme environments like near Chernobyl. And in 2019, samples of the fungus were flown on the ISS and observed over a period of 30 days. The growth rates were measured, as well as how much radiation was passing through the fungus compared to a control that had no fungus. And the results were that the radiation below the 1.7 millimeter thick bed of fungus was 2.17% lower than the control, and the fungus grew about 21% faster than it does on Earth. So neat, but don't get too excited. To bring radiation levels down to Earth level on Mars, the habitat would have to be covered by a 2.3 meter thick layer of fungus. And the same effect would be achieved by covering a habitat in 3 meters of Mars regolith. But it is an interesting thing to consider for the future. For now, more mundane solutions are going to be used in the near future. For example, the uncrewed Artemis 1 mission to the moon will be testing a protective vest for the astronauts to wear.
And that flight is next February. Yeah, very near. Yeah, it's interesting. I think we've thought about using biological solutions for mitigating radiation exposure before, but this is the first time that I think that I've actually read, some empirical numerical results from it. And 2% doesn't sound a lot, but as you say, Julie, if you increase the thickness, you end up with a reasonable amount of shielding. Could be very advantageous in the future.
And that's
sure.
right now. I mean, we could end up with different ways to grow this fungus, different ways to utilize it, different genetic edits to it to boost its radiation absorption. There's a lot that can be done, and this is really just, I think, the first step in a long series of steps that will hopefully eventually lead to this being a biological solution for radiation protection.
Yeah, agreed. I mean, there would be a number of other things we'd want to consider as well. Well, I mean, I guess if we're sending people to Mars, we're sending us and all our biology with us too. So what's an extra organism? But we do go out of our way, pitching missions into gas giant planets to not contaminate moons. There would be definitely some interesting considerations before sending Earth biologicals to another planet.
Especially ones that thrive on radiation.
True. I mean, whichever way we cut it, when we're talking about, going to Mars, because that's the one planet that I think we're most concerned about. Going to the moon, I think everybody is quite content to believe that the moon is a sterile environment. So taking up some fungi up there is probably not nearly as much of an issue as taking fungi to Mars. But if we go to Mars at all, you're contaminating the surface there. And so if there is indigenous Martian life, then we're already, at risk, shall we say, in them contaminating us and us contaminating them. As you say, Julie, the extra fungus is not going to be much of an issue, I don't think.
I mean, our track record is pretty bad, though, even on our own planet.
Yeah.
I mean, as an Australian.
I'm not sure where we're going with this.
I mean, Australia is just like, let's bring over these toads. Oops. Oh. Let's bring over rabbits.
These rabbits.
Oops.
Yes. Hey, we weren't Australians at that point in time, okay?
Well, fair. And I'm not saying it's the Australians that sent the stuff over. I'm just saying that poor Australia.
Yes, this is true.
Has become a very strong example for what not to do.
Quite true.
As far as introducing biological things to places that they are not native.
And we won't even talk about the camels.
Okay. Oh, boy.
I don't even know about the camels.
Oh, yeah, we got camels roaming the outback. Wild camels.
Oh, my gosh.
Yeah. They're a little easier to find than the rabbits, though. Anyway.
Nicer than cassowaries, anyway.
I don't think we've got any of those. No. Ryan, there was news today of a rather reprehensible event in space.
Yeah, we kind of alluded to this a little bit earlier in the show. And to be honest, I've only known about this story for a few hours and thought it was important to talk about this evening. So let's start with kind of the start of the day. Some ISS astronauts were told early this morning by NASA that due to a satellite breakup, there was a debris field that was created near the ISS orbital path. And in assessing this type of situation, engineers at NASA kind of create a pizza box area around the ISS with a 0.75 kilometer height above or below, altitude-wise, above or below the space station, and about 25 kilometers in radius in either direction, leading or tailing it. And if something comes into that, it's very hard to avoid. But outside of that, the space station can burn its thrusters, move above or below any particular debris field. Now, astronauts and cosmonauts in the ISS, they were actually instructed at one point to close hatches on several outward-facing modules on the space station, and to actually get into a shelter-in-place emergency situation where they go into the Soyuz capsule and the Crew Dragon capsule as the space station goes through two passes of this debris field. So the NASA engineers who were looking at this basically said the next two passes, or I think it was the second and third pass of this orbital debris field, could be dangerous enough that something terrible could happen. The astronauts were immediately put into this emergency state where they go into the capsules, And if something did happen to the space station, they could be used as lifeboats to get the astronauts safely back to Earth. Now, as time went on throughout the day, the cause of this giant debris field was revealed to be a Russian anti-satellite test taken against one of their own and outdated satellites. So it was a test by the Russians to see if they could destroy a satellite. And they chose one of their own, sure. But this satellite, called Cosmos 1408, which doesn't operate anymore, very outdated, it weighs about 4,400 pounds and is orbiting about 485 kilometers above the Earth, so not far from the orbital altitude of the space station. Well, this explosion, this anti-satellite test, created a debris field of over 1,500 pieces of trackable debris. That doesn't count the likely thousands of smaller pieces that can't be tracked in this giant expanding debris cloud. And so the now, of course, is very dangerous. The astronauts had to shelter in place. Luckily, nothing serious seemed to come of it, thankfully, especially since not only were there American and European astronauts on board, that there were actually Russian cosmonauts on board. And so although it's dangerous today, it's also dangerous for the foreseeable future, as this cloud of debris is going to continue orbiting the Earth as it expands. It can pose a risk to the space station, to China's Tiangong space station, and to future launches that now have to plan for this extra debris field in orbit, in a very useful orbital space. And so it was just really interesting to see how this unfolded. And I want to read the statement from Bill Nelson, who's the current NASA administrator, part of his statement. "I am outraged by this irresponsible and destabilizing action. With its long and storied history in human spaceflight, it is unthinkable that Russia would endanger not only the American and international partner astronauts on the ISS, but also their own cosmonauts. Their actions are reckless and dangerous, threatening as well the Chinese space station and the taikonauts on board." So very, very strong words from NASA. And this story has just unfolded today. So we'll have to see kind of what happens, what comes of it in the coming days. But one thing that is for sure is that there is now a new cloud of debris, over 1,500 pieces of trackable debris now to consider in future launches and future orbit paths of the space station.
Unbelievable is the only thing I'm going to say. I mean, talk about straining relationships between NASA and Roscosmos at the very minimum. But it's something that you've just told us, Ryan, is going to last for literally, potentially years. And that debris, of course, is not just a threat to the International Space Station, but low Earth orbit is a really busy place. Unbelievable.
I don't know what it's going to mean in the future. I mean, it's certainly just the implication of something like this from a partner nation of the ISS. It's such a reckless, endangering act. What's the point?
It probably also tells us that Roscosmos likely didn't know very much about what was happening. I'm betting that the Russian military were obviously the ones who were behind the test, and they kept Roscosmos in the dark. I'm going to put the charitable spin on that. It doesn't change the fact that the Russian government has endangered low Earth orbit and their own cosmonauts, but I'd like to believe that Roscosmos themselves were not party to the action.
Well, I mean, they are, because even if they don't know about it, they are part of the Russian government. Mm-hmm. And are certainly responsible, whether they want to admit they had no prior knowledge or not. It's so we'll have to see kind of what the response will be.
I can't imagine. I mean, they're going to say that they've got their own rights to defend and they're sovereign and so on and so forth. I can see this becoming just a political football, but as I say, reprehensible. We've all spoken about space debris for years, and to think that this has actually happened, very sad. I'm going to call a halt to it there, folks, because we could chat about this for quite a while, but I wanted to make sure that we got it in. Just a quickie note to everybody, this coming Friday morning from 2:15 in the morning till 5:45, there is a near total lunar eclipse that's visible across almost all of North America. Maximum eclipse obscuration is at 4:09 in the morning, 97%. You'll get all of the good stuff of the eclipse, but you won't see full totality. Anyway, so that's this coming Friday morning here in North America. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan I. Carswell Observatory. Ryan, Julie, myself, keeping you company on this Monday night, Astronomy Night in Canada. Stay tuned for Quirks and Quarks, Science for the People, and Western Worlds. Until next week, good night from me.
Good evening.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is